Hello, welcome back. Today in this video we are going to solve a problem on a rigid body rotation motion. This problem says like there are three particles. There are three particles A, B and C. Okay, there are three particles A, B, C, each of mass m are connected to each other by three massless rigid body. Means these three body means three masses A, B, C connected to massless rod form a rigid body, and it form an equilateral triangle of side L. Equilateral triangle of side L. Okay. This body is placed horizontal, frictionless table XY. This whole body is placed into a table, horizontal table. Okay, this whole body is placed into horizontal table. Okay, let's assume this is the horizontal table and this body is placed there. Okay, and is hinged at point A, and this point A is pivoted here, right, so that it can move without friction about a vertical axis. It can move like this, it can move, revolve like this, okay, without any friction, with constant angular acceleration omega, constant angular velocity omega, right? There is no friction here in this hinge, and here it's moving without any currently is moving without any frictions. Okay, and this moving with angular velocity omega. First you need to find the magnitude of horizontal force exerted by hinge. Magnitude of horizontal force, how much horizontal force this hinge is applying on the body, on this whole body. The first and second problem, at time t, when side BC is parallel to x-axis, a force F is applied on B along BC as in figure. Obtain the x component and y component of the force exerted by the hinge on the body immediately after time t. Just immediately after time t, once it is aligned to x-axis. Okay, first we need to find out the total horizontal force acted on this body. Okay, this whole body, we can assume this whole body as a one small body, and we can, like, it is a table, and here one body is pivoted, and here this is moving in this direction. Okay, it's moving in this direction. We need to find out center of mass, right? This whole 3 mass 3m must be, is like it's connected to some center of mass here. Okay, why I'm taking this weight also, because just it's a hinge, and it's this, we have to take this mass into account also. The total means first center of mass would be like total length L, then this length will be center of mass. Okay, means L by root 3. Center of mass, not center of mass, radius of gyration, we can say radius of gyration would be L by root 3. Radius of gyration would be L by root 3. Okay, it's very simple to find out this radius of gyration. It's actually, this should be, means this point from this point to this point, and the center cm, center of mass, should have equal distance from each m, right? Means this r and this r are equal, and this angle is 30 degree angle, and then you can find out the relation between R and L, right? How? to find out sine 30, just apply simple trigonometry. Sine 30 divided by r is equal to sine 120 divided by is equal to sine 120 divided by L. Okay, this is 120 here, right? And then this one sine 31 by 2, this is root 3 by 2, then L will be equal to root 3r. Root 3r you can solve and you will get it. Okay, this center of mass is this point, and now it's look like it's just moving around this axis. Then whatever is the centripetal force, that force thing will be applying the same force, right? Centripetal force means we need to find out centripetal force or centrifugal force. Okay, that centripetal force will be mr omega square. Total mass, this is total mass of the body, total mass m total, and r is the radius of gyration, this one, and omega square, right? That is given. Then this total force exerted by this things would be m means 3m, r is L by root 3, and omega square, that is the total force, means root 3 ml omega square. This is the horizontal force applied by these things, this things we can say. Okay, next section of this problem. At time t when BC is parallel to x-axis, means this is my x-axis, this one is x-axis. When BC is parallel to x-axis, a force F is applied on B along BC. Along BC, a force F is being applied. Obtain the x component and y component of force exerted by the things on the body. Here one force F is applied at the time t. At the time t, one force F is applied to the body. We need to find out just immediately after time t, total x component and y component of force, right? At t is equal to t, when this is there in horizontal position, a force F is applied. Okay, but at that moment only, once t is greater than t, this force will be removed. Okay, now you see that we at this moment total force, component of force would be what? In x direction. First we will see in x direction. X direction total force will be F plus Fx, right? Here this is Fx, and that will be equal to mass of the system. Mass of the system is 3m, and acceleration, because of this force, this whole system will get, for a moment, will get an linear acceleration a. Let's take as a. Okay, in x direction. This is F plus Fx is equal to 3ma. And what about Fy? Fy, because there's no force applied in the y direction, then Fy would be equal to simply this root 3, simply this one, right? This should be a root 3 ml omega square, right? Obtain the x component, y component of a force exerted. Now challenge part is a. I need to put the value of a here. Okay, because an external force F is applied to the system, there must be some torque, right? Some torque must be will play some role over here, because this is fixed, this point is fixed, then this force F, this force F will exert some torque, and the torque value would be F into the perpendicular distance, right? This distance, this is any distance P, perpendicular distance. Then total is L, this length is L, this length is L, this angle will be 30 degree. You can find out what would be the value of this one. The root 3L by 2, I guess. Root 3L by 2 is the P value. Okay, the total torque will be F into root 3L by 2. Okay, this is L, this one is 30 degree, that is a base, and this is perpendicular, so this one will be 60, this one will be 60, 30, and you need to find out this one, so cos 30 root 3L by 2, correct. Now tau is F into, and tau will be I alpha. Okay, tau will be I alpha. What would be the value of I? I is like mr square, right? M L1 square, ml square, ml2 square, means m l square plus m l square again, right? From here we can find out, right? This is I, because it's revolving around this, right? Revolving around this, the ml square, that total I into alpha. Okay, so we have 2 ml square, means f root 3 by 2 into L should be equal to this bunch of thing, means 2 ml square into alpha. From here we can find out the value of alpha. Alpha would be 1 L will get cancelled, F root 3 by 4 L. Okay, this is the value of alpha. Now we need to find out A. A is equal to R alpha, some distance alpha, R alpha, right? What is the value of R over here in this case? Because if fx is equal to 3ma, this R should be equal to this perpendicular distance. Okay, this R should be radius of gyration, means this radius, this distance means L by root 3. This should be L by root 3, means L alpha by root 3. So we got value of A, that will be equal to, if you put the value here, you will get F root 3 will get cancelled, F by 4L. Okay, if you put it here, you will get A is equal to F by 4L. Now you substitute this value, F plus Fx is equal to 3ma, F plus Fx is equal to F plus Fx is equal to 3ma, where A is 3f. Actually here you will get m also, m here, m 3f 3ma, 3f, m will get cancelled by 4. Okay, and here f plus fx, right? Now you get the value of x, 3f by 4 minus f. Okay, you got fx would be f by 4 minus f by 4, whatever. Okay, and you got fx. Similarly you got fy we have already got. Fy is root 3 ml omega square, and fx is minus f by 4.